So just remember there were three types of equations for parabolas. The standard form, y is equal to ax squared plus bx minus plus c. Then we have the vertex form with vertex hk, y is equal to a x minus h squared plus k. And we have the equation for the intercept form, which I'm going to highlight in yellow right here, which is what we're using for today's lesson, which gives us the roots, the zeros of our function, the values that make our y be 0 in our parabola. So this next problem asks you to describe the quadratic relation with respect to its general shape, whether it's up, down, it's a stretch or compression or whatever. So all of the a values that we have in each of these equations, the a values tell us whether our graph is positive or negative, right? Whether it opens up or opens down. So if I'm looking at my basic equation here, what this equation tells us right off the bat, it can tell us whether it opens up or down or whether it's stretched. So based on the 2 in this equation, this parabola opens up, and the 2 also, because it's greater than 1, tells us that our graph has a stretch factor of 2. Now, the other thing that we need here for this sketch, anytime I ask you for some key points on a graph, I'm usually looking for the y-intercept or the x-intercepts, right? Let's quickly calculate the y-intercept for this parabola. Problem we're ending up with our value for our y-intercept being 6. Now I'll just graph that. So there we have our y-intercept of 6, and now we need our x-intercept. So when we were finding our x-intercepts for this specific type of parabola, this is what we would normally have done. We would have let y equals 0. So I'm going to explain to you why our solutions for the x-intercepts are the way they are. So let's say I have 0. So y is equal to 0. So I'm going to write 2, x minus 1, x minus 3. So when we're solving for it, our x-intercepts fall out of here because of this bracket here, x minus 1. Well, it's equal to 0 because 2 times 0 would give us 0. And we're looking for a value of x that makes this 0. And this part here, x minus 3, is also equal to 0. So this is actually an OR statement. So either x minus 1 equals 0 or x minus 3 equals 0. So we end up with x equals 1 being our x-intercept and x equals 3 being our other x-intercept. So that's where we get the idea of the x-intercepts for our parabola when it's in intercept form. Now, another way of looking at this is if I have x minus 3 in my original bracket, I know that the x-intercept is 3. If I'm looking here, I know the x-intercept is 1. It's just the opposite of what's inside that bracket. So now, that's all we call it. Now, another term for our x-intercept is called the roots, and I'll show you why it's the roots right now. So if you think about it, the roots of anything are some things that are rooted, are grounded on a certain spot. So we look at the x-axis as our horizontal, and anything that touches the x-axis we call a root. So it is the root of the function. So x equals 1 is a root and x equals 3 is a root. So just remember, anytime I say these, anytime I say I want the roots of something, I'm looking for the x-intercepts. So now, when we look at our parabola, there's only one thing missing with this parabola. We don't know how far it actually goes down for its vertex. Now, in our investigation, we decided that if we found the axis of symmetry by looking at the roots, we could easily find the vertex. So let's do that right now. So with my vertex calc, the first thing that we said that we had to do is we had to find our x-intercepts. We got them. And now we have to calculate our axis of symmetry. So the AOS is equal to the average of the two axes of symmetry. So in this case, we're going to go 1 plus 3 divided by 2. So that means we have 4 over 2, which is 2. So that means our axis of symmetry is x equals 2. So now that we have our axis of symmetry, we're going to use our axis of symmetry to find our vertex because it goes through the axis of symmetry. So we're going to sub 2 into y is equal to 2, x minus 1, x minus 3. And we're going to get this. And when we simplify, we end up with y is equal to 2 times 1 times negative 1, which ends up being y is equal to negative 2. So now that we know that when we sub in x equals 2, we end up with y equals negative 2. So therefore, the vertex is 2, negative 2. So now let's go and plot that on our graph. And so when we plot that on our graph, there is our last point for our graph. And if you recall, this is where our axis of symmetry is. So now we have our y value on our y-intercept, and we can find its mirrored point across from it. And then what we can do is we can take a moment and quickly sketch the graph. And there is our graph. Okay, so just recall, there's three major steps. So 1, we find our y-intercept. 2, we find our x-intercepts and graph them. 3, we do this vertex calculation, which consists of finding the axis of symmetry and then finding the y value of the vertex. Okay, and we're done. We take those last points and graph.